In this video, I'm going to talk about exponential equations with different bases. Truthfully, we always wish that the bases were the same because it's easy. But when you have to do different bases, it's like, ugh. Okay, but we can do it. So let's say I'm going to make up one right now. If I say 3 to the x equals 9. The bases are different. So I can't solve it right now until the bases are different. Well, can I turn this big guy into a small base? Doesn't 9 really equal 3 squared? Well, if I wrote it like this, then it would be the same base. Do you see that? So what if I say 3 to the x equals 3 squared? Now I have the same base. Now all I have to do is do it what I did in the last video, and that is x equals 2. And there you go. So here, x has to equal 2. 3 squared is 9. Do you see how that works? So, you know, it didn't start off with the same base, but we made it be the same base. We kind of forced it to be the same base. What if I say this? 5 to the x is 125. Now, your job is to see if you can turn this into a base 5. Is 5 times something times, is there something that 5 can work with to make it 125? Let's say you don't know. Let's say you don't know. Here's what you could do. You could go 5 times 5 equals. Does that equal 125? No. Well, then try it again. Times 5 equals. All right, now it's 125. Well, how many 5s did you do? You did 3. So watch. 5 to the x equals 5 to the third power. You just figured that out on your calculator. Now the bases are the same, and now you can just solve for x, and x equals 3. Do you see that? Make sure you're copying all this down, guys, okay? All right, how about another one here? What if I would say 4 to the x equals 2 to the x minus 3. Now, they're not the same base, but can I make this big guy into the small base? Yes, I can. Because doesn't 4 really equal 2 squared? Doesn't that equal 4? Now I've got the same base. To the x power equals 2 to the x minus 3. Now when we see this, all we do is really the distributive property. You're just going to multiply x times 2. So now 2 to the 2x equals 2 to the x minus 3. Now we're going to just go 2x equals x minus 3. And we're going to solve like this. So minus x. And 2x minus 1x is just x equals negative 3. So in that case, x is going to equal negative 3. All right. Let's do another one. Just like the other one. Okay. How about this? 9 to the x plus 2 equals 27 to the x. All right. Now, is there any way that you can turn 27 into a base of 9? Does 9 times 9 times anything like that equal 27? I'm not saying does 9 times 3 equal it. I'm saying does 9 times 9, it's 81. So you can't turn 27 into a base of 9. You can't turn 27 into a base of 9, all right? So is there a different base that you could turn both of those into? Guys, I don't know about you, but when I see a 9 and a 27, I think 3. Because 9 is really 3 squared, isn't it? 3 squared. And 27 is 3 cubed, isn't it? All right, now I just throw this on there. X plus 2 equals x. All right, now remember, we're going to multiply this out like a distributive property. So you're going to multiply this times this, then this times this. All right, so it's going to be 3 to the 2x plus 4 equals 3 to the 3x. Now they're the same base, how gladly. So we're just going to go 2x plus 4 equals 3x. And I'm going to go minus 2x on this side, minus 2x. 4 equals x. So in that case, we got 4 equals x. All right, that's how you do these exponents with different bases. Either you're going to take the big guy and turn him into the small guy base, or you're going to change both of them into a different base.